Hi everyone, I want to show you how to use Desmos. That was a request by a student. Okay, so Desmos, I already have Desmos on my computer. So you just need to, if you don't have it, go to the URL here and type in desmos.com. And since I already have Desmos pop up already on my computer, it will just pop up. Here are some important areas. This side is just telling you where to put your function representation. The function representation is here. The graph representation of the function is over here. Here are some tools to help build your function. So if you open this tab keypad, okay, you'll see X and Y. Now this is an X and Y function. So if you use T and Z for variables, you would have to define them. So best to just change your function to always X and Y. It makes it a lot easier to deal with. Okay, so X and Y here, and this is for X squared and or any value to the second power or any value to any value. So for instance, I can type in y equal. I don't need y equal, but I can type in y equal, or I can type in f of x, okay, equals some x squared. So as you begin to type, even if you're not done with your function, you can see the graph starts to immediately, once you get an equation going, immediately tries to put in the function for you, create the representation. So this is a representation of in function form and graphical form. So let me continue. So I'm going to square that. Notice when I square it, my cursor is in the same position. It's not in the upper part of the 2. So I can go +3. And as you can see, my function is changing as we write. I can also say plus x to the 5th power. So I'm going to use AB. So when I do to the 5th power or use the B function, it stays up there, wants me to type up there. So I type, but notice that it didn't come down. I can either use this arrow on my keyboard, computer keyboard, the keyboard in Desmos, or on my computer keyboard, I can use the arrow. Once I use the arrow, you see I can add more to it. Okay, so I'm just going to take that off so I can see. Now, Desmos tries to provide some points, critical points for you. This is the point of inflection, and this is the point of interception of the y-intercept. So these are common, even though you don't have a table. Now, suppose you want more points. You want to see more points. You want to identify certain things. You can go to the gearbox here. It says edit list. It will give you a table to convert this function. Now you have 3 representation of this function. You have the function itself written in standard form. You have a graphical view, and you have a table view. Now, every time you add to your table, you will see it will be here on the graph itself. Now we have a -2, and it's at -25. We can't see that. You can move this keyboard and scroll down, click on, and try to scroll down, or zoom out, and scroll down, and there it is. -2 at -25. And so that's one way. You can add more to it. Doesn't matter the position. So if I'm here at 2 and I hit enter, since it's already at 2, I will just give me 3. Notice when you add 1, it adds it to the graph itself. So it's all the way up here. So let me go back. 3 is at 200. This is 2. 3 is at 200. So wow, instead of going all the way like this to 200 to find it, 255 to find it, we can change the gearbox. We can use this wrench to change the window. So go here to change the window. You click on the window. Your Y, we need to change the window so we can see the Y a little better. So we're at 255, so I would say 300. And so the negative part of my y, I also want to see the negative part of my y, but maybe negative 27. So I get a chance to see here at 2 and here at 3 in the same view, okay? So my x is still scaled by 5, and here I'm scaled on the y by 50. All right, so it automatically did that for me. Now, if I just wanted to zoom in and out without me actually classifying the scale, I can do that. So I can zoom in or I can zoom out, okay? And if you don't want to see this to be in the center, click and hold and just move the cursor up. Now this wrench here can do a lot more. If you don't like the white, the black on white, you can reverse it and make it the white on black. If your eyes are perfect and want to look like that. We're not blind, so we don't need Braille. So here is a grid. So we can remove the grid altogether. We can add arrows here and here. We can take the arrows off or just add it at the major end. Okay, so right here and right here. We can put the grid back. We can take off axis numbers so we don't see any numbers. And we can get rid of these smaller grids. If we remove the grid altogether, we just have an X and Y plane, okay? But of course, it always looks good on grid and with it being numbered. All right, here again is to change the window, but we can label it too. Say this was, X was time and in hours. And Y, the label was concentration of drugs, and that's in microgram per liter. So you can see it labeled it for you. Now, if the function didn't need the x-axis being in a negative, nor the y-axis being negative, being only a one using the first quadrant, so you can slide it over and move it down, and there you go. You're only seeing one quadrant. Well, because I covered up the axis line, this the label moved over here. So if you want to push it back over so you can get the label, and that's fine. So now you're only focusing on one quadrant. As opposed to you doing it yourself, moving it about, you could also allow this wrench to do it for you. By changing the window on the negative side of the Y, we can make that 0. So we can make that 0. And we can make the Y, the X on that side also 0. Okay, so it did it for us. So it's far down, so it's not quite easy to see. You can't see the lines at all. So whatever your choice is, you can always click back and move. But notice once you click and move, inside here, it changed immediately. It has to modify itself, so it changed immediately. Okay, you can also use it for, instead of a Cartesian graph, you can use it as a unit circle. And you can use radians or degrees in your unit circle. Okay, so here I have 90 degrees, or I can change it to radians, so it's pi over 2. So I'm not using that, I'm using a regular Cartesian graph. So if we want to compare a graph with another graph, we can add another graph right on it. Okay, so we can say, we don't have to say y equal or f of x equal, we can just put that graph there. So at 200x divided by x plus 2. Okay, so we can see that we have an asymptote at -2, And we can see we have a vertical asymptote at -2 and a horizontal asymptote at 200. And sometimes you can see the 200 right here, but another good way to really highlight that is to actually put the what? Put the asymptotes in. X equals -2 and Y equals 200. So you can see, so if you want to move this around, the Y, you can see, you can change that range if you want, going from -10 to 0 to 200. Okay, so here is the asymptote. It's going closer and closer as long as you move it. Now it will eventually go look like one merged on top of each other, but it will never pass it. Just because the computer is trying to get as close as possible, it looks like it actually is 200. No, it never reached 200. That's just the way the computer is reflecting it, but you understand that asymptotes, you never get there. It just looks like you get there. So same thing for X. You can see how close it's getting to this purple. The black asymptote is, vertical asymptote is in the black, and how the function in purple is getting closer and closer and closer to the point where it will actually look like it's right on top of it, but it will never pass. It will never go beyond it, only because that's just the way the computer looks. So these are some tools that you can use to help you use Desmos the best. All right. I hope this was a great help for you.